Hello, and welcome to AI at the Edge Day with Embedded Computing Design. This roundtable session is Navigating AI at the Edge, a technical deep dive with Tria Technologies, Music.ai, DFI, and Nordic Semiconductor. I'm Ken Briota, Editor in Chief for Embedded Computing Design, and I'll be your host and moderator for today. If you're not familiar with us, please visit embeddedcomputing.com where you'll find our coverage of everything related to the design of hardware and software for embedded systems. We're chock full of design articles, white papers, blogs, videos, podcasts, and lots more. And we're always adding new content and technology coverage. In today's roundtable, we're going to be looking at how AI at the edge is transforming the way that data is processed, interpreted, and acted upon closer to the source. But unlocking its full potential requires coordination across a diverse ecosystem of stakeholders, from silicon vendors and embedded engineers to data scientists, software architects, and system integrators. This technical roundtable brings together experts across the AI stack to address the practical challenges and innovations driving edge AI deployment today. Our panelists today will be Monica Houston, Manager of AI and ML for Tria Technologies, Matt Henninger, VP Business Development at Music.ai, Jerry Chang, Marketing and Strategic Sourcing Center Senior Director at DFI, and Wojciech Bober, Technical Product Manager at Nordic Semiconductor. Before we get started, let me just quickly go over a couple of housekeeping items. This entire presentation will likely take between 45 and 55 minutes. Please feel free to ask your questions throughout the presentation, and we will try and answer them as they come in. So we'll be taking questions throughout the entire course of the discussion. You'll find on the right side of your console window an area where you can enter your questions in real time. As I said, we'll address as many as we can. If you have a technical difficulty or a question pertaining to the webinar itself, like your slides aren't advancing or there's trouble with the audio, please put that into the question box, and one of our technicians will respond as soon as they can with a fix. The on demand version of this webcast will be available about 24 hours after we sign off today. So if you missed something, you want to go back and review or share any of this presentation with a colleague or a friend, you can find it again through the same link that you used to sign in today. A reminder that all Open Systems Media webcasts are copyrighted and may not be recorded without prior permission. So, without further ado, why don't we get into our discussion as we bring our panelists all back to the forefront here? Welcome, everybody. I'm very excited to have ourselves a little roundtable discussion here. Reminder to everyone out there watching and listening that you can send questions in throughout the presentation, and I hope you do. But let's jump right in with one directed here at our friends at Nordic Semiconductor. Wojciech, you're up first. What is needed out there, and what is possible for AI at the edge in terms of memory, connectivity, power efficiency? A big one to get us started.
Yeah, it's a good question. I think the Edge AI has been well established in some areas, like more powerful devices for vision and anomaly detection. But where we see a gap and where we um, think there is a new field and new capabilities is pushing the Edge AI even to the smallest devices and allowing the product vendors and developers to add features that rely on Edge AI. And where I would say the standard would be models for, let's say, kilobytes or hundreds of kilobytes in the parameters and above for more powerful devices. We're looking at the models that are even below 10 kilobytes for, time series data and applications such as activity recognition or anomaly detection. I think the boundary is getting pushed, and especially on the sizes and also on availability of running this because of small models and low latency times on battery powered devices. So um, I hope you other speakers can help me on the more powerful devices that are available.
Well, yeah, I'd love to hear what everybody thinks on this. There's a lot of elbow room, but what do you think is the big need for AI right now? Uh,
I'm
what about you, Matt? You look eager.
yeah. It's just coffee. It's not eager. I think from our side, there seems to be this interesting kind of fork in the road or a paradigm shift between we have companies coming to us and looking for they've either made technology choices and are leaning on old chips and somewhere in their production cycle where they're now trying to fit a new idea or new product idea that might involve audio AI into that device and saying here are sort of the parameters and the specs of something we've already ordered. So how small can you make it? And let's give you latency times and let's start to drive into a product there to what he was mentioning about sort of like latency, battery power, right? You sort of like, I've already made some decisions, so now make it work, right? And versus you have some more forward-looking companies that are now looking probably into the next year and the next product cycle where we're starting to lean on more powerful chips, Qualcomm, AMD. These folks are saying, look, I have a product vision that takes me into next year. What do I need in order to support it? So we see a very, very big fork in the road as our prospects and customers come in. They've already made technical decisions and we have to adapt, which can help from there, can help in a cost perspective in one way because maybe that's already been ordered and they're saving money, but puts huge resources on the development side and re-architecting and retraining and things like that versus again the runway and the pathway to lean into some of the more powerful chips where I think this is all going. But I see it shifting already from that, like looking in the rearview mirror to looking forward has already happened, I think, in our business in like the last year.
Yeah. Jerry, Monica, you want to jump in on this, or we can?
Yeah,
I have a question, but I want to hear what you guys think about this first.
yeah. Well, just for this kind of this question, like we need to take care about like for the AI application, like we need to think about the endurance and for the lifetime and the reliability for long terms. So sometimes we need to check about the life cycle and also rugged certification. And so the efficiency is essential and the reliability sustain is for running many for long time is really crucial for AI application. For my opinion.
Yeah.
I'll jump in if you've.
Yeah.
Matt mentioned Qualcomm, so that's what we've been working with a lot at TRIA. And I was just thinking, like, just 2 years ago, doing generative AI or running an LLM at the edge would have been like, it was not sure if that was going to be feasible. And now it's like,
Yeah.
almost everyone seems to be focusing on that. So it's amazing how fast things have changed and how Edge AI now encompasses things that, boards that are able to run, they have 100 TOPS of power on their NPU. So it's rapidly changing, and I think it's going to be changing more as model demands increase.
Yeah.
And we have, there's the idea of adaptive AI, even where you're going to do training at the edge. And so that seems like a pipe dream now, but that's definitely in the, it's coming, I think.
Yeah, I think so. And that's going to lead to a little more full adoption of things like agentic AI at the edge and things like that once we can do a lot more of that processing. Although we do have a few folks out there claiming that they're running it already, but we don't need to get too bogged down in that. And we could probably talk just about this one question for the entire time, but I would be remiss if I didn't move us forward. But I do want to touch on one other thing before we do, and that's the power efficiency part of this question. Obviously, everyone's aware that especially generative AI can be a huge power draw in a system. So a lot of engineering is going toward efficiency and careful there. And a thing that I think might be needed is a way to be better at self-powering edge devices. We're doing a lot of stuff with, trying to do solar if they're outdoors or various other power methods. And I'd love to hear what you guys have been seeing out in the world in terms of trying to, I don't even know if you'd call it a minuscule grid, a really like almost self-powering, although not quite that devices for these edge AI systems? I mean, does that seem like a thing that you've heard people working on or developing toward? Anybody feel free to jump in here. I know it's a big question and it's big future thinking, but I'm curious.
not not self-powering so much as I haven't gotten to that sort of that end point of that conversation yet, but there's definitely been a massive focus, especially in the audio space. We're fielding a lot of requests for real-time source separation on device. So to
Okay.
be able to, and this is taking us into the path of, battery-powered Bluetooth speakers, right? And
Yeah.
can you really move these things into, I think one of our last projects was like just slightly over 1 tops, right? Can you really squeeze these things out? And it's all about battery. How long is the speaker going to run? How efficient can you make it? And some of our larger customers, it's many iterations, right? Of sort of how much smaller can you make it? How much faster and so I see a big push to that again. But no, I haven't gotten to that point yet. I have definitely we've seen a lot of RFPs and a lot of questions about like how, what are you really going to be doing to my system? Right. And that cost benefit analysis, right, of like that drain against the value to the customer. Companies seem to be spending a lot of time focused there right now.
Yeah.
Yeah, I can say that, in the space where Nordic has always had a strong presence, which is, for example, wearables, right? You see this class of devices where you have the edge AI processing and devices starting to be solar powered, for example, watches, right? So there are vendors who are producing watches that will get, so this push for squeezing the, every milliwatt of the device and allowing really low power inference is, of course, there.
Yeah, absolutely.
So
I'm
different
going to
type of
move us.
devices.
Yeah. I'm going to move us forward to our next question. Folks out there watching, joining us, thank you so much for being here with us. Please feel free to send your questions into that Q&A box, and we'll get to them as they come in and as we're moving right along here. So that's a reminder for you. We're taking questions throughout our discussion. All right, this puts you on the stage here for Tria Tech. As a generative AI and multimodal models move closer to the edge, what new architectural or integration challenges will we face? Monica, you get to go first this time.
Okay. Clearly, I'm obsessed with generative AI right now on the edge because that's what we're focusing on with some of these Qualcomm boards that are super powerful. And one of the main challenges is memory, running these data pipelines. The token windows are quite large for many of these models. Obviously, the models are changing every day. So we have these, small language models like Phi 3. We have Llama 7 billion. And so but they're still memory intensive. So it's not just about like the raw inference speed and having a lot of TOPS on your NPU. It's also about making sure that your interconnects, your memory are large enough and fast enough to not cause a bottleneck, and also to balance your connectivity, your image pipeline, your language and your vision models. All of these are taking different resources and making sure that they're not starving each other on your constrained hardware is really important. Additionally, there's a lot of challenges with like tool sets. So making sure that you have the ability using with your tool chain to adapt your model to the edge is really important, to be able to optimize it, quantize it, whatever is needed, and keep the performance and the accuracy. So, and then finally scaling. So like having options, because these models are constantly changing, having options like PCIe to add NVMe or to add additional accelerators is a huge bonus.
Yeah, absolutely. I think that sort of upgradability and that modularity is going to be a key design element for all of the edge and edge AI stuff for sure. Does anybody else want to jump in here and talk Gen AI for a minute and what challenges you're seeing out there in the world?
Yeah, as you can talk about, like maybe we all know this iPhone 17 just launched, and that means you can see the trend for the hardware side for edge device. You can in the future you will have a CPU, you will have a GPU and the NPU, and I think the challenge is your software need to find the right architecture or the right algorithm to use the right power. I mean, you have CPU for all kind of AI, then CPU, GPU, then NPU, then with most efficient way. So that's a challenging. And I mean, in the future, your edge AI, like a different device, not only maybe iPhone, you have all kind of device. You can have different kind of computing, and you will have a different ability and different strengths and different uh, power for AI. And the challenge you need to find how to just squeeze out the AI and with a balanced, efficient, and balanced way to use your edge device.
Yeah, I couldn't agree more. That balance of use is really, really important. I'm curious about the challenge, and I've seen a few companies talking about this as they're implementing Gen AI, especially at the edge of using small language models and custom proprietary trained data sets and algorithms and stuff. Are you folks seeing that sort of as a growing thing, the best practice or standard practice now? Are people still sort of trying to tap into large language models at the edge for Gen AI? What are you seeing out there?
Yeah, me for like a same example like iPhone, they use their AirPod to have translation, instant translation. And it's based on like a small language model. Then you can use this kind of a model, and it will help the change the game. I mean, it will change our life. And so everyone just talk about AI like 20 or 30 years ago. The internet like changed the architecture of how we trade our technology. And then now the AI will change it the same way that it will change the basically to the way we see our life, because we'll change how we just connect to each other. So that in the future, maybe we really through the translation, maybe we can show the virtual way to everyone. I have no idea, but I think that's very interesting. Like the small language model will be more popular in the future.
Anyone else want to jump in before we move forward?
Yeah, for for our business, we've had to make a decision as you're talking about, sort of like the. I know this is our conversation is focused very much on the edge and moving the processing to that, but we have, for example, we have a consumer app called Moises that has about 65 million users now. And the primary, and this is the it's ubiquitous to desktop and mobile and everything like that. But what we've been having to make these decisions on, some of the core technologies there are source separation and lyric transcription and sort of anything you can do. Think about it sort of like the ultimate music creation practice tool, right? But what we realized is, as from an efficiency standpoint, obviously some of the newer chips are very interesting to us. I mean, moving some of our processing off of the cloud into the device would be helpful as we think about the business. But we're also trying to find that line of how to democratize the technology in the right way, so that we're not limiting it to just the higher performing phones, because we really think that we can fundamentally change expectations and how users are moving through content. So decisions that we made, for example, and the way that we have to train our models, everything has to be licensed. The music, obviously, very litigious space, and we have to be very, very careful about generations and derivatives and all of these things. So we've we just released our first sort of generative model for essentially STEM-based track creation. So the idea being you could create a voice memo on your phone and you could STEM separate it out into guitar and voice. and then that becomes the input parameter, and then you can say, give me a bass player or give me a drummer, and just like, let me iterate on this idea. But we realized that in order to propagate that different way of consuming or creating, it had to stay off of the edge, it had to stay on the cloud, because we wanted to ensure that that functionality made it downstream into other devices, and we weren't creating a cutoff point. So from a business side, that's always sort of, I mean, you guys can talk circles around me from the technical standpoint, but like, that's something that we find ourselves constantly thinking about, is like the democratization and who we want to introduce to these technologies, and sort of what like barriers of entry that we're putting. So for us, if we can put one of the smaller models on device, and we watch as those chips sort of trickle down to cheaper and cheaper devices, sort of where can we plant that versus where do we want to keep our models on the cloud, and base that against the user experience.
Yeah. We have an audience question that we're going to go to next here. This one's kind of really interesting. What are the greatest challenges to edge AI for signals or sensing that are not sound or vision related? So I assume touch, haptic feedback, vibration, I guess would all qualify there, but I'm sure others. What are some of the challenges for edge AI for those other sensing, or is it just sort of similar to vision and sound? And anybody feel free to jump in. Matt, I understand you not jumping in. Sound is pretty specific for you guys.
Of all of the ones that I'm definitely tapping out of, like I can't even kind of help here.
Wojciech, have you been doing anything outside of the vision and sound sense realm?
Yes. So we like the vision for Nordic vision is I would say the limit of what we're really positioned to do. So our devices are in terms of memory around 2 megabytes of memory, and then you have 500K to 1 meg of RAM. Those are like tiny devices for wearables, for accessories. So obviously there is like Gen AI is the cool kid. We're kind of on the pushing the AI from 20 years into those tiny devices. Like how do you can bring that? So of course, from our perspective, and this is I guess not that different, is getting the quality data to build out those models, and this is not that different from I would say any other AI problems, right? So quality data and all the data engineering that needs to go, especially where you're solving these problems that are very, I would say, customized. Like if you're building an anomaly detection, this will be customer to customer and case to case.
Yeah, for sure. Monica, I know Tria messes around with a lot of this stuff and so I'm curious to hear your point of view here, whether or not you've seen some difference in challenge for non-sound or vision sensing.
I echo the data problem, because I think it is a lot harder than image data sets. There's a lot of existing data sets and pre-trained models that you can kind of start out with and test, but like it's very customized. Additionally, choosing the right processing blocks, like to get the right features, can be very difficult. So whether what kind of the feature extraction part is crucial, and having nice visualizations for that can be really nice. I love using like Edge Impulse has really nice tools for that. So plug Edge Impulse. Yeah.
A little side plug for Edge Impulse there. Always welcome. Well, why don't we push forward? Thanks for that question, Randy. I'll call you out by name. Appreciate that question. But Wojciech, you're gonna come back to the front of the line as we ask, what are the key decisions engineers face when deploying Edge AI, and how does Nordic address those challenges? Everybody else will get a shot. I won't say Nordic when I ask you.
Right. So I think, we started a little bit in the previous question. I think the first foremost one is to ask yourself, do I have the competence to actually get the data and do this by myself? Because we know from a lot of research that the failure rate for projects that try to deploy AI is higher than any other software projects, and one of the most cited reason is actually failure of the data engineering, right? So that would be the first. So do I do it on my own, or do I rely on a partner that maybe have experience? And then, of course, if you decide that, then what device we're talking about, the edge AI, what device will fit in the power budget, in the cost, in the and the even in the size. So we're in the wearables accessories where the real estate on the PCB matters, right? So it's not only that. So we of course are pushing the size and the power consumption and the power budget lower and lower, and then we go outside of that. Like once you deploy the application, once you have it in the field, the job is not done. How do you make sure that the model works? How do you make sure that you can observe how it performs and maybe update it in the future? So we are not only offering these technologies that allow you to build the models, we are offering the devices that allow you to run, but we're now made some strategic acquisitions that hopefully will result in this machine learning life cycle, addressing the machine learning life cycle.
Awesome.
What kind of update schedules are you seeing, or like being requested? Like, are you seeing a consistency or like a trend forming on sort of like what sort of expectations there are for updating these things, for retraining? I'm just sort of curious.
We are still early, so we're learning, but there are different reasons customers might want to update. Of course, one of is that you want to improve the model performance, but another reason that is maybe a little bit independent is customization. So I told you that the devices we have are very small. So let's say you're doing a keyword spotting device, very simple assistant, right? And then you have models to work in different localization with different languages. We are not able to fit the model that will work with all the languages because the device is too small, right? So you have to do this over the air, for example, depending on where the device is, in order to have one SKU, right? So this will be one-off update. And then for the models, it will be, on the range of months, months to, I would say, quarters.
That's very cool. What about you, Jerry? What are some of the things that your engineers are trying to address when they're looking to deploy Edge AI?
I think the key decision you need to make sure when you apply a AI engine or AI application function, you need to take care about really just resolve your pain point, not just want to do AI because your boss say you need to do AI. So that's important. So that means you need to think about really what the AI model, AI engine you got really right to find your customer need. So sometimes we observe our customers sometimes just do AI because their boss say. Then that mean you were running with the wrong model or use the wrong hardware or you just want to do something, may just prove that you do some AI job. But we think the most important thing to write, you really need to resolve the pain point and to find and really the model you got really it is just so we provide the customer like offshore product, like we help them to integrate software and hardware, and but we don't need to let everyone to develop the algorithm because we need to just deploy the right model. So we need to have the to find the right one, and we just need to modification to from the existing model to our product. So that's a challenge, and the thing we need to think about the pain point. The key part is the pain point.
Okay. And what about you, Monica? Are you seeing your engineers hitting key things, or are they standard engineering problems, basically?
I think choosing the right board, does that count as deployment? Choosing the right board is definitely the hardest thing, the first thing you have to do. And it kind of influences everything else, because it influences what your tool chain is available, all your power constraints, your connectivity. So that, and then I guess that's the big one. Your life cycle also of your product. So
It would be nice if they would just design one board that would work for everything. Right. That'd make everybody's life a lot simpler. I wish somebody would get started on that. Now, Matt, I think you've probably got an interesting sort of different answer from everybody on this one, as you're often deploying on like consumer devices, right? A lot of the time. So what are some of the things that your engineers are thinking about when deploying on devices that somebody else owns functionally?
Yeah, I mean, to what Monica was saying, I mean, a lot of it is board choices. It's like trying. I find myself in a lot of my conversations, especially in the consumer space, is really pressing the engineering groups and the product teams on the why. Like fundamentally, why are we doing this? Because to that point that was brought up earlier, like I feel like there's this business checkbox that has just exploded, where everyone's got to have an AI strategy, or it's got to be incorporated. And you can, like, if I've been learning that if you really press on the why for a while, it's usually not there, or it's not understood, or it's a misalignment and that sort of thing. So, a lot of what we're doing is trying to understand how is the user going to benefit? How does this fundamentally change the way the device is being used? Because sometimes we have to, like I said, it's something just as simple as like source separation, removing the vocalist from any track. So think of like anything becoming study music or lo-fi music, right? Or something like that. Even that, like, to understand why we're doing it and for what kind of music we're doing it and what region we're doing it, it's all just customization and that sort of thing. So, I think, I don't want to speak for my engineering team because they kill me, but the truth is, I think a lot of what it is just, I don't want my team to bring in some of these projects as potential partnerships where success isn't truly defined, right? Where it's like, where we can't, the worst thing I can do is hang my engineering team or anyone, or my data science team out to dry, because I don't really have my head around why we're doing something and what success looks like. And we've seen a lot of projects hit the floor because success isn't defined because of like some ubiquitous AI strategy from a customer. So I think that's a lot of what we're doing right now, is just saying, like, what are the key decisions? Like, how do I really make sure that my team, or we're asking the right questions and pushing in the right spots, so there's success is actually achievable, right? The data does exist to solve this problem, things like that.
Yeah. When people don't ask those questions, that's how you end up with walking into your kitchen in the morning, telling your toaster to make your toast, and hearing, "I'm afraid I can't do that, Dave." Let's not get lost in there.
Yeah.
All right. Jerry, I think you're first up on deck here as we ask, how do we choose the right edge AI platform for long-term use? I love this question because I think a lot of the thinking is still short-term, as we're so early in this world. So how should we be thinking about long-term edge AI use?
Yeah, it's a great question. And to explain this, I like to use an interesting analogy here, Uber Eats. because it maybe it's different for different it's different story for different country, but because eating out is very popular in Taiwan, and many restaurants also provide takeout service. So Uber Eats business is booming in Taiwan, and we will trade like NVIDIA's AI products like big trucks, and they pack huge horsepower and can hold heavy loads, and but it consume a lot of fuel, and these trucks are ideal for long hauls, but where road performance matters. Most of the fuel cost may be not really a huge concern, but increase Uber Eats in Taiwan drivers most use scooters, and lighter, more fuel efficient, and perfect size for zipping through the narrow alleys. And it's similar to Edge AI platform, like just like this. Maybe we have different device to deliver the data computing or AI computing. So when the cloud AI focus on the maximum performance without worrying about power or heat, but edge device need operate everywhere, and in factory, hospital, transportation. So the power efficiency, heat dissipation, and the long-term reliability over 5 or 10 years are just very crucial as performance. So for a total cost ownership standpoint, picking the most powerful platform isn't always the best option. HAI requires the balancing power, energy consuming, and also thermal design and the ruggedness. That's why DeFi offer a diverse range of platform beyond not only NVIDIA's, include Intel, AMD, Qualcomm-based options, so customer can choose the right solution depending on whether they need a raw horsepower or energy efficiency or specialized I/O connectivity. And customers sometimes we need to talk about the AI. It will just related to the IoT. It means the Internet of Things. So security is another priority, especially given rising concern and the new regulation like Europe's Cyber Resilience Act. To address this, DeFi partnered with Canonical to integrate Ubuntu Pro for the long-term security updates and the maintenance directly into our platform. So this will help us stay secure and compliant for 5 to 10 years. So in summary, it's not just about horsepower, it's about providing customer with a balanced, efficient, and rugged, and also secure platform, and deliver reliable performance throughout their full life cycle. Much like choosing the right vehicle, whether it's a powerful trunk or nimble scooter for their AI job. So it's
I couldn't agree more. I think that
yeah.
planning for that long-term support is the real secret, especially in terms of security and customizability. Although I do look forward to one of our listeners out there hearing your example and me trying to get an interview with the CEO of Vespa.edge, the new company starting up next year. I'm
Yeah.
sure I'll see that coming now. In the interest of time, I want to get through as many of these discussion points as I can. I'm going to tell everyone they don't get to comment on this as we move to our next question, because I think we've got a lot to cover, and I don't want to miss out on too many of these. Wojciech, you're up next again. First, as Edge AI becomes more ubiquitous, how important is it to have an integrated hardware and software solution? And I think this one might be the critical issue. So let's hear what you have to say.
Yeah, so from our perspective, the hardware, even the simplest devices, and we're working with the Cortex-M type of class of devices. Even though devices and the software stack and the hardware stack is getting more and more complex, right? So this requires more and more knowledge to build a device that is power optimized and will be able to meet your power budget. So I think it's more important that that this integration and optimization comes from the vendor, from the silicon vendor like us, that gets you started much easier. That could have been
I don't know.
done
I think
by
we might have
someone else.
lost. Oh, there you
Yeah,
are.
sorry, yeah. So just what I said is the last sentence I said is that I think it's more and more important so that you as a product vendor can focus on just the application and adding the value rather than optimizing the platform for your needs and purposes.
Yeah, absolutely. I think that's true. Does anyone else want to jump in on this one when it comes to integrating hardware and software? And I know historically those have stayed in sort of their own silos and then argued with each other in the back alleys of the code. But I'd love to hear if anyone else is doing finding advantage in that integration or disadvantage. Even I'm here for either side.
And for DeFi, we have a very special solution for this kind of question. Like we co-op with our vendor like Intel or some software vendor use the virtual machine, because sometimes you can use virtual machine to just have to deploy different layer for hardware, different layer for software. So it will save time for adapting different kind of interface. So we have this kind of experience that we can use different kind of virtual machine to resolve this kind of I think not really problem is it's needed another resource to customize or to do adapting different kind of hardware and software. So that's some idea from DeFi. Yeah.
Yeah. All right. Hearing nobody else jumping in, I'm going to move to our next question. And if I remember correctly, Matt, you're up next. um, so, is the music and audio space leaning toward fully embedded deployments, or is really the cloud still the preferred method? Are you finding sort of a hybrid or middle ground solution? Where is the sort of state of the union?
Yeah, yes. It's from what finds my desk. It's the advancement of the product versus the cost to the business to deliver it. And we're powering through a cloud platform. Music AI is fundamentally a cloud services platform with 70 different models and 6 or 7 different companies, and you can come in and kind of put these things together. But when our customers are coming in and thinking about scale, they get scared fundamentally about really the meter running, right? Like the fundamentally
Yep.
per minute processing, unknown variables inside of their pipeline, customer acquisition, and they lose. So I felt like the initial push into embedded was actually cost protection versus anything else. Like it was like, I want it off, I want it to run, I want to pay for it once, and I never want to hear about it again. And that was like how they could safely start to iterate their product using these models. Although then there's the deficiency of them, right? We're limited by performance, we're limited by all the things versus like all the scales and everything's state of the art, everything's updated automatically on the cloud. Like we're constantly keeping you state of the art, right? There's just sort of that rub. And so I think that the path is probably going to be in the middle. I think that there's going to see some standardization of SDKs and things where like some core technology in the audio space can be brought on the edge in a variety of devices, and we can start, and then it'll look, like when not there, we'll start to go for more complex processes when connectivity exists. And truthfully, the solution, and I think what I've been trying to do, I don't know if it's going to be successful, but was to bring on the idea of like concurrency based processing and things like that to the cloud so that I could give a fixed price. I could open up a pipe and give a fixed price to processing, just to try and alleviate some of that concern, to find out, are we putting things on the edge because we have to, because we want to, or because there are valid concerns and there are some that we're fishing. So, I think it's going to move constantly, but I also think that like it's probably going to settle in the middle where There are some services that are used to offline processing, digital audio workstations, and anyone building videos, like they're used to being offline for security reasons. You don't want albums to movies to leak, right? They're going to have requirements that way. But, I see it starting to become a hybrid.
It's interesting. Before coming into the embedded computing space, I spent a long time covering IoT specifically and the sort of come up of that industry. And I found that discussion also happening. We had the first big wave where everything was going to be IoT connected and networked and blah, 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 blah. And then after a while, people started having the discussion about, well, okay, maybe some of this stuff doesn't need to be, or we can do a hub and spoke model, or we can do some other things. And it seems like the AI explosion where everything's going to have some AI tool is now starting to reach that more mature, or whatever you want to call it, phase where it's, okay, let's look at the use case here. Let's not just throw it in for the blurb on the website about it. Let's make sure it's more practical. Does that feel like that's sort of the phase we're moving into, or already in the edge AI space?
Totally agree. I totally agree with you. I also don't know if it's just sort of my being naive to it, but fundamentally it's like, I thought the first, because I've been with music AI noises for about 4 years now. And I thought that the big first push was everything bigger, more processing, more powerful, right? Like that was all anyone wanted to talk about, was sort of how big everything was getting and the breadth of what it could do. And then in my head, the startups that were maturing in the space were the ones that started to talk about how small it could get faster. Right? Like whoever started, like the ones that were going to survive were the ones going, okay, well, we could do that, but no, like success can be really amazing right here. And now look at the flexibility born from something small. Yeah. And so I felt that natural contraction, but and at the business level of it, but it was just like, it became like a litmus test when I was talking to all these companies and they're trying to figure out their strategy. Is if they were starting to talk about bespoke, really, really customized things and solving very specific problems, it was like, oh yeah, you're on the right side of this. Like, I think, yeah. So I would agree with you. From my desk, that I see the same thing.
Yeah. We are eating up the time, guys. This is such a fun discussion. Reminder to you folks out there listening and watching, feel free to send questions in. We've got about 10 minutes left on this session. So we do have time to get to at least one or two of your questions if you send them in. But for right now, Monica, I'm putting you on the spot because I've ever since I first put this question into the queue, I've been looking forward to this one because I want to hear about this. What gaps still exist in the tool chains for moving from cloud trained models to real-time edge inference? Because man, is that a challenge.
Yeah, it is. Well, one of the things that makes it harder is oftentimes the documentation is for these tools isn't complete. There's amazing tools now, a lot of proprietary tools for certain hardware that let you quantize and optimize and convert your models in just a couple steps. But if it shouldn't take you 2 weeks to find out that the operator you thought was supported actually isn't supported, and there's no way to, convert your model that you've already trained. So documentation is really important. Also, there should be a balance between, control, like being able to accelerate different parts of the model and different parts of the hardware, like versus ease of use. So if you have a lot of flexibility and control, sometimes it makes it really hard to use these tools. And the documentation, it shouldn't just like throw you into the deep end where you need a PhD to figure it out. It should be, I think NXP and Renaissance do this really well, where they like slowly ease you in to being able to run the model and convert it. And then you get into the more complicated stuff eventually. And then finally, being able to measure your optimizations is really important. So profiling and benchmarking are really important because oftentimes, when you quantize or even when you convert a model to run at the edge, it will change the accuracy. So it's really important to get not just the your latency and throughput numbers, but also your accuracy numbers and your memory. Look at being able to see how much memory you're using. So including tools like that I think that's kind of that's still a gap that needs to be filled. Yeah.
That accuracy point is a big one. The verification of the outcomes and the results is a processing drain on top of the drain of just accessing and doing the inference against the model and the data inputs and all that stuff. Do you find that there's a processing limitation that becomes a challenge on the sort of hardware engineering side, or even a latency and speed trade-off depending in these translations from cloud models into the edge inference model?
Do you mean like if
like basically is that an additional challenge in this sort of translation process over to make sure that that you're able to layer all of these additional things into a thing where if you're just running off the cloud, your accuracy rate might be better anyway, so you don't have to worry as much.
Yeah, it's a trade-off. So it's really important to be able to, get the numbers easily so you can trade them off. So, maybe you don't want to quantize to N8, maybe you want to do N16 instead, because that's where the accuracy actually makes sense for you. So it's really important to have tools that easily get you both of those numbers so you can compare and contrast and decide.
Yeah, absolutely. Has anyone else run into either challenges in moving from your cloud trained model to the real time edge, or other found gaps in the tool chains where you've had to solve some of these problems?
I need to talk about, maybe we talk about the cloud chain or need a real-time chain, and we need to talk about the balance, because everyone talk about ESG now. I mean, if we really take care about ESG, we need to turn down every AI. So that mean we still need to develop AI. So imagine that in the future we will have an AI ecosystem, AI chain, like we will have a monster cloud AI like in Amazon, Google. Then we have some just private cloud in every company, and also we will have maybe your private cloud in your home. So in the future we have a different cloud everywhere. I mean, the cloud is maybe edge cloud, and that means we will resolve, like your device could. Because if we just use only for the Amazon cloud or Google cloud, the latency will always be the limitation or the bandwidth problem. So if we can have a different edge cloud, then we can have a better performance for this kind of problem. Yeah.
Yeah, for sure. And I think that that sort of collaborative nature transitions us lovely into what is likely to be our last question here as I move us forward. And Jerry, you're gonna get first swing here. What I mean, the idea of letting the market decide with edge AI, I think is an interesting one, but really, I think it's going to be about what does the the buying market want, and what can those of us who are making these things provide them. So I'd love to hear your thoughts on this question on working together and letting the market decide, and I'd love to hear everybody on this topic, because I think it's a big one and it's a great way to end as we get close to the end here.
Yeah, okay. At DFI, we just see ourselves as a crucial bridge in the AI supply chain. So helping navigate the huge and complex AI ecosystem that involve everywhere, and for the hardware makers or software developer and the integrator, our role is to make sure all these diverse pieces communicate smoothly by providing reliable, flexible embedded hardware, and support a broad range of CPU architecture like x86 and ARM. So there's no single winners or the one size fits all solution in edge AI. It's just like there's no single vehicle that fits every trip. So sometimes we need just a powerful trunk. Sometimes we have a limbo scooter, or even a bicycle. And so that's why DFI doesn't rely solely on a single platform. NVIDIA, Intel, AMD, Qualcomm, and so we have a wide variety variety allows let us to meet the different needs and industrial and give the customer flexible choice and tailor for their specific application. And that means we can move fragmented pieces to a cohesive, secure, and high-performance AI deploy. Give customer the confidence that their complex AI system will work smoothly today, and just have a better choice and have an offshore product for them. Yeah.
Yeah, I think you're absolutely right. And since we're here in a collaborative sort of roundtable discussion, I think that partnership ecosystem is particularly critical in in edge AI development and largely in embedded engineering as a whole. You know, uh, it's a rare company, if any, that can be all things for all use cases. And so, really, the wise move, as you guys have all very clearly discovered, is to be the expert in the thing that you do and do it better than anybody else. So I'd love to hear a little bit about how you find advantage in the partner ecosystem as we move through our last question. And Monica, I'll put you on the spot next.
Great. Okay. So I love these partner ecosystems. I love going to conferences, and like I feel like conferences are a type of collaboration. When you go to like Embedded World or something, you're seeing what everybody else is doing and you're comparing notes. And there's so much space for us to work together on the software stack and not reinvent the wheel, which is crucial. So working together, like I also think there's a lot of really cool platforms like Hugging Face and Kaggle and even Hackster.io. Also, we publish all of our reference designs on GitHub because we want to encourage that, like, foster that kind of open source mindset of we're sharing what we have and like people can take it and innovate with it. But it makes it, I hate to see waste. Like I guess like I'm an engineer, I love efficiency. So if we can, use some of these open source tools, standards, it just makes things a lot easier.
Yeah, and thank you for the opportunity to do another unasked for plug, but for Embedded World North America coming up in Anaheim pretty soon. I'll be there. I know some of you folks will be too. So you listeners, get yourselves registered while you still can. Matt, you're up next. Why don't you tell us a little bit about how you work with partners and where you find advantage there?
Yeah, it's been interesting. I'll take like a slightly different spin on it. It's been interesting to watch from our perspective, kind of coming in with the products and the consumer app and the things that we have and the embedded models, like how different stakeholders seem to have very different priorities and also have very different storytelling. So I've seen like DSPs and apps and folks like that have a very clear idea of how these things can affect their business and be helpful. I'm seeing the same thing. Consumer speakers, desktops, like there's a clear, like they have like, I can see how this can affect my user experience and bring new value to my customer. I'm also seeing like we're having conversations with a ton of major chip manufacturers. And I've been a little surprised that they, in my opinion, are struggling to articulate the value of these new line of chipsets. Like these are massively powerful NPU, and they're like the story. They seem to be clamoring for actual use cases that like change the way, that leverage the technology to change the way their users interact with their product. And it's been interesting, like battery life. I was on one, then it was like, that was going to be the big pitch for another new chip was battery life. And I was like, whoa, these things are doing so, like, no, you can remove the underlying music from any video. Like you can do some crazy, like you can do these crazy lights, like the stuff that we're talking about. Like it's mind blowing to me what these things can do, but they're figuring out how to leverage it and tell that story. So for my partners, I have been truly impressed at the ISMIR and the open source community and everything that's like, I mean, when I joined the company, they were, Moises said, absolutely, we're going to actually train our own data sets and release them for free for open source training because to support the community. It was so foreign to me, that idea, right? Of like the collaboration on the model and the training, and I've been blown away by it. But on the other side, it's been so interesting to watch this technology kind of lead the conversation where everyone's like, I don't even know what this can do, but I need to tell a story about it. And that's been another very interesting thing to me, is to watch different stakeholders that I'm not used to dealing with really grapple with that. Like, how do I really make this impactful for everybody? It's been very interesting.
Yeah, absolutely. And Wojciech, I will ask you to be brief as we are getting very close to the end of our time, but I'd love to hear your thoughts.
Yeah, for sure. And Nordic has, believed in collaboration for a long time, and this has mainly manifested in joining the Zephyr project, which is the real-time operating system, where we've been from the very beginning, and we're endorsing this collaborative effort. So I think the open source and working together is the future, and it has been future for. It has been something for the operating system. It's going to be probably for the edge AI as well.
I think that's very, very true. Unfortunately, this does bring us to the end. And as you folks just saw me flash through, there were a lot of questions that we did not have time to get to. So maybe we'll have to do a sequel at some point. But for now, I'm afraid that's the end of our time. Remember, all of you out there will receive a link to the archive of this conversation so you can view it again later. I'd like to thank all of our panelists, Monica Houston of Tria Technologies, Matt Henninger of Music.ai, Jerry Chang of DFI, and Wojciech Bober of Nordic Semiconductor for this great discussion and for sponsoring this event. One last note, make sure that you subscribe to our AI at the Edge newsletter on embeddedcomputing.com so you never miss any of our embedded AI news. And a final thank you to you listeners out there, because of course, none of these events or discussions would be possible without you, the engineers. Thank you all for attending. Please join us for the rest of our AI at the Edge day here, and have a great rest of your day. Thanks, everybody.
Bye-bye.
Thank
Bye-bye.
you.